Okay, 9.1, multiplying and dividing rational expressions. This is just like multiplying and dividing fractions, only now we're going to do with rational expressions. It's really the same thing. So, objectives. Students will be able to simplify rational expressions and complex fractions. A couple things here. A ratio of two polynomial expressions is called a, you guessed it, rational expression. Here we go. So, rational expression. Alright, so we're going to just simplify a couple of these. Here's some steps to follow when doing this. Factor out the greatest common factor first. Look for difference of squares or other traditional factors that you know you can do, like difference of cubes or sum of cubes. And then just cancel. Cancel. Okay, so here's the monomial. This one's easy. Well, what goes into 27 and 9? Well, 9 goes into both of these. So 9 goes into 27 3 times, and it goes into 9 once. What goes into x cubed and x fourth? Well, x cubed goes into both of these. So we could cancel out the whole x cubed, and that leaves it with just one x. And the y's cancel each other out. So really all we're left with on top here is just a negative 3. And on bottom all we're left with is a 1 and an x. That's it. So we could just say negative 3 over x. That would be our answer. Now, even though we canceled out x and y here, we still need to write the restrictions for what they cannot be. So let's think about this real quick. What can we plug in for x that would make the whole denominator 0? Because we cannot divide by 0. Well, if we plugged in a 0, the whole thing would equal 0. So that's one restriction. What about y? Well, it's the same thing because we're just multiplying together, so we can't plug in a 0 for y either. So we have to make note of those as restrictions. So those should be included with our answers. Now, sometimes in the back of your textbook, they won't really include those. But a lot of times on tests, I'm going to be looking that you've noted those. So keep practicing noting all your restrictions. All right. Here's a practice one. Why don't you guys see if you could take a factor out of the top and out of the bottom. See if you can factor these down before you do anything. Look for the greatest common factor first. Go ahead and try that on your own. You can pause the video and then I'll show you what it should look like. Okay, here we go. So when you factor this, I pulled a 2 out of both, leaves me with 2 times x minus 3. And when I factor this thing, I pulled a 3 out, leaving me with 3 times x minus 3. Well, you can see that these x minus 3's cancel. But really, before you cancel, you should make a note. What could you plug into x to make the whole denominator equal 0? Well, here, if you plugged in a 3, 3 minus 3 is 0, and 0 times 3 is 0. So x really cannot equal positive 3. If it did, the whole thing would break down. So we make a note of that, and then we cancel, and then all we're left with is 2/3. And they're done. We can move on to the next problem. Let's do it. Alright, when you get a problem like this, you're going to have to factor it. On top, it's the same thing as before. We can factor out a 3 out of both of these. We get 3 times x plus 2. Now on bottom, we're going to need to factor this. Now I taught you guys a long time ago to do the star, put the 8 on top, the 6 on bottom, and see what's something that multiplies up to 8 and adds up to 6. You don't really need to draw the star to do that though. Couldn't you just look at this and say, hey, what's something that multiplies up to 8 but adds up to 6? How about 2 and 4? So that means in the bottom you could write x plus 2 and x plus 4. And before you cancel, just like I looked here, I guess I forgot to actually put it here. So before you cancel, you may want to say check for restrictions. So what does that mean? Well, same thing we've been doing here. Now that I've factored this, what could I plug in for here that would make this thing equal 0? Well, that would be negative 2, right? Because negative 2 plus 2 equals 0. What could I plug in for here to make this thing equal 0? That would be negative 4. So that means that x cannot equal negative 2 or negative 4. All right, now that we've made a note of our restrictions, x can equal negative 2, negative 4, now we can cancel. Look, I got an x plus 2 on bottom, and I got an x plus 2 on top. That leaves me with just a 3 over x plus 4. So that's my answer with this restriction. Even though we canceled it, we still need to make note of that, because later on when we get into graphing, this is still important. Okay. Once you guys try this one, you're going to factor the top and factor the bottom. same way we were doing it before. I think you could do it. In fact, I think that you could probably do these next two, just factor them both. This one here, I'm going to just tell you, this one has a difference of squares going on. So you may want to pause the video because I'm going to put the answers for both these up in just a second. Okay, for example number 2b here, I factor the top, and it's x minus 5 and x minus 5. And on the bottom, it's x minus 5 and x plus 4. So I wrote my restrictions real quick. It can't equal negative 4 or 5, and then I canceled them out, and that's my answer. All I'm left with is an x minus 5 over an x plus 4. All right, next one. Top one is a difference of squares, so I get an x plus 4 and x minus 4. And I pulled a 2 out of every single term. Remember, if there's a greatest common factor, you need to pull that out first. So I get 2x squared plus 3x minus 4. And now I'm going to see if I can factor this thing. I can do negative 1 and positive 4. Negative 1 times 4 is negative 4, and negative 1 plus 4 is positive 3. So I factor that out. Here's my restrictions. X can't equal negative 4, and it can't equal positive 1. Cancel them out, and I'm left with x minus 4 over 2 times x minus 1. And that's it. So that's just simplifying. Now let's talk about multiplying. Well, multiplying is really just like you just kind of go straight across. You can kind of ignore that little multiply sign and just kind of put parentheses like this. Really, that's all you're doing. But in order to make your life easier, see if you can factor these things, because things will start to cancel. So here I got a difference of squares. That's going to be a plus 4, or not plus 4 actually. It'd be a plus 2 times a minus 2. And on bottom it would be a plus 1 times a minus 1. And then now on top, if I just extend this line, I have an a plus 1 up here. And then here I can pull out an a from both of these. So you get an a just kind of all by itself, and be left with an a plus 2. So what would my restrictions be? Well, what can a not equal? Let's look. It can't equal negative 1. It can't equal positive 1. If I plugged in a 0 here, the whole thing would be 0, so it can't equal 0. And it can't equal negative 2 here. So there's 4 restrictions on this one. Now let's cancel a plus 2, a plus 2, a plus 1, a plus 1. What am I left with? Just an a minus 2 on top and an a times a minus 1 on bottom. And that's it. So that's how you multiply them. Really, you're just going straight across. Kind of add some parentheses, factor them down, see if anything cancels, mark your restrictions, and then just simplify. So try this one on your own. See if there's anything you can factor out of all the terms. So go ahead and try this one. I'm going to pause the video and put the answer up in a second. Okay, when you factor this thing, you should get a 5 and an x. That doesn't really factor much more. But you can pull out a 10, get an x plus 1. Pull out a 5, get an x plus 1, and then leave the 10 down here. And then things cancel like crazy. Oh, also you should mark your restriction. X can't equal negative 1. But look, 5 and 5 cancel out. X plus 1 and x plus 1, 10 and 10. All you're left with is just an x. So your answer here is just x, with the restriction that x cannot equal negative 1. All right, let's try this one. Again, first thing we're going to do is just kind of write these all as a factored form, but extend this line. So x squared minus 4 is x plus 2, x minus 2. X squared minus 9 is x plus 3, x minus 3. This, well, multiplies up to 9 but adds up to 6, is 3 and 3. So this is going to be x plus 3 and x plus 3. And this is going to be x plus 2 and x plus 2 because it multiplies up to 4 and adds up to 4. And we got a lot of restrictions we can mark here. Actually, there's just 2, really, because this is a duplicate, and this is a duplicate. So x cannot equal negative 3 and negative 2. All right, let's see what cancels. X plus 3, x plus 3, x plus 2, x plus 2. And that's it. I'm left with x minus 2 times x minus 3 over x plus 3 times x plus 2. And that's as simple as you can go. All right, try this one. Factor them both. There's no difference in squares, but you can factor them all using the star. There's no coefficient in front of the leading term, so it should be pretty simple. So go ahead and factor it. You may want to pause the video because I'm going to put the answer up in just a second. All right, when you factor this top one, I get x minus 1, x minus 4. Here I get minus 1 plus 3. Down here I get minus 4 and plus 7. And here I get plus 3 plus 7. My restrictions then would be positive 4, negative 7, negative 3, and then negative 7 again. Okay, and then you can see if things cancel. You got an x minus 4, an x minus 4, an x plus 3, x plus 3, and then you're left with an x minus 1, an x minus 1, x plus 7, x plus 7. Well, you can just write that as an x minus 1 squared and x plus 7 squared, and you're done. All right, let's go on to the next page.